Let's look at this problem. So a piston of cross-sectional area of 25 square meters is used in a hydraulic press to exert a small force of magnitude 98 newtons on the enclosed liquid. A connecting pipe leads to a larger piston of cross-sectional area 250 square meters. What force will the larger piston sustain without moving? So what do we have? We have a piston of cross-sectional area A1, and that would be 25 square meters. And we can exert a small force on that. And let's call this force F1, and it has a magnitude of 98. So F1 is 98 newtons. Alright, a connecting pipe leads to a larger piston, so let's connect this to a larger piston. And the piston has a cross-sectional area A2, which is 250 square meters. What force will the larger piston sustain without moving? So how do we know what principle to use here? There are some key words that should clue us into what the principle is that we are supposed to be using. One of them is the hydraulic press. So hydraulic press usually go with Pascal's principle. The other thing is that we have a liquid that is not moving. So the liquid is at rest. So in problems that have liquid at rest, we can only use two principles, and one would be Pascal's principle, the other one is Archimedes' principle. And we're not submerging anything in the fluid, so we can't use Archimedes' principle for this. There's no buoyant force. But what we can use is Pascal's principle. So again, the problem says that we have a force F1 that's pressing down on this surface area A1, and then there is a liquid all through here, and this liquid then will exert a force F2 on the larger area A2. So I'm going to draw force F2 here. And we know that at this height, there will be the same pressure. So pressure 1 is equal to pressure 2. Pressure 1 equals pressure 2 means force 1 over area 1 equals force 2 over area 2, because pressure is force divided by area. So we know force 1, we know area 1, we know area 2. We have to solve for the force 2. So F2 is F1 A2 over A1. Plugging in the numbers, F1 is 98 newtons. Area 2 is 250 square meters. Area 1 is 25 square meters. So the units for meters cancel out, and we're left with 250 divided by 25. That would be 10. 10 times 98 is 980 newtons. So force 2 here acting on the larger piston is also larger, and it's 980 newtons. Small force over a small area means large force over a larger area.